Hello, once again, we are here with Professor Misha. We spoke about pi in a previous podcast. I would like to continue. Misha got some fascinating piece of biblical pi and some other things we are going to discuss, I'm sure. So let's go for it.
Okay, thank you. So we were just to recap a little bit of what we said last time. It was very important for the ancient people, ancient Babylonians, Shumers, Egyptians, Greeks, to understand the number of pi and calculate it. So much so that it looks like it was a very well guarded state secret.
Mm-hmm.
What is the real number? The official number which people were coming from with, it was basically 3 and 1/8, 3.15 in Babylonian time, which is quite far from the real number of pi. I was only much later, at the time of the 3rd century AD, when genius of the ancient world, Archimedes.
Archimedes, yeah, with
Yes.
the polygons, we spoke about it a bit before, but it's very interesting to mention again. He used a circle and he put a polygon outside it and inside it, and then he created an estimation, pretty good, very good estimation of pi.
Interestingly enough, the polygon was starting from the triangle,
Mm-hmm.
and on each iteration they doubled the number of the vertices. So from triangle it becoming like 6
Mm-hmm.
vertices, 12, etc., etc. So he came up with a 96,
Yeah.
which is the last one, obviously before the 100, and he got the approximation, which is basically 3 and 1/7, or 22 divided by 7. And we also spoke last time that the number 22, number 7 obviously everybody knows that it's an extremely significant number because of the 7 colors and 7 days of the week, etc., etc. But also 22 is quite significant number because, for example, in Jewish tradition, Kabbalah says that, and basically Judaism says that the world was created through the words of the Hebrew alphabet, and there are 22 letters of Hebrew alphabet, so it's very important. If we look at numerology, also numbers 11, number 22 is very, very important. Obviously 11 is a prime number of 22.
So Archimedes did a great job at the estimation, but, and this is the beautiful piece of information that I'm looking at.
So basically, well, it was interesting for me to see what the Bible have to say that, and we also mentioned last time that kind of there was a certain contradiction, certain kind of fight over centuries, especially last, say, 3-4 centuries, between the science and religion.
Mm-hmm.
And science very often tried to disprove religion by kind of pointing that in the old religious documents, the numbers, the things were not very precise.
Yeah, exactly. Then inaccuracies, hence, these people were not really using scientific method. They didn't care about the discourse and about the
The most famous of these things was obviously heliocentric model of the world versus kind of things going around the earth that
gave the church a lot of material to.
That Copernicus basically published it on the year of his departure from this world, because that's already he was out of the reach of religious persecution. The same time everybody knows about Galileo Galilei, so this kind of very much in the people's consciousness, and unfortunately we kind of living to the consequences of this kind of disparity, this kind of fight between the religion and the science. So I was interested what the Bible has to say about the pi.
Mm-hmm.
And the first glance, it looked extremely kind of dissatisfying.
I remember the feeling, yes.
Because the verse which is talking about it's 1 Kings 7:23, chapter 7, verse 23.
Chapter 7, yes, Perek Zayin we call it in Hebrew.
Yes, so basically please look at it. So it talks about the King Solomon and the building basically the circle,
Mm-hmm.
and it says that the diameter is 10 units,
Yes.
and the line, the circumference
30.
is 30. which you don't have to be.
It doesn't look good, it doesn't look good when you look at it for the first time.
It gives three,
Yeah.
three as a pi, which is actually poor. Well, King Solomon was living 10th century before Common Era, so it was about 9 centuries after Hammurabi. So Babylon was very. So basically, the question, guys, could you not have?
Yeah.
And also, like in many traditions, in Jewish tradition, in Islamic tradition, King Solomon has absolutely unbelievable reputation as the widest person.
Exactly, the most intelligent man in the world. Yes.
Suleiman ibn Dawood in Islamic tradition. So how kind of under his supervision we can look at the pi being 3, while already Babylonians about 1,000 years ago understood it as being 3.125.
I think the people of the Pythagoras cult probably would have been satisfied with him because they loved all numbers. They worshipped numbers as all numbers, so maybe they would have been just happy with that. 3 as a. No, I'm just making a joke, of course not. But you can come up, go. Yes, we go.
Yes, in a way, yes. That's very, very interesting point. And well, normal kind of explanation of this fact is that the Bible is not supposed to teach us about the numbers. Mm-hmm. It's not a book of mathematics. Very interestingly, you said about the kind of the sanctity, the holiness of the numbers of the Pythagoras, would say. Yeah. And obviously, although Pythagoras was like 5th century, 5th century before Common Era, and this was 10th century, the kind of the tradition which kind of he was drinking from.
Yes.
It was also Middle Eastern tradition, which kind of the ancient kingdom of Israel was part of. But still, kind of 3 didn't satisfy me until I come across a completely fascinating thing, because in the writing of the Old Hebrew Bible, there are kind of few occasions, not very many, when there is a writing and reading of the things contradicts each other.
Kri v'chtiv.
Kri v'chtiv. And in this very pasuk, in this very verse, not in the book, not in the chapter, but in this very verse, not even in the very verse, but in the word just before saying 30 units, there is a word line, like circumference, the line, and it says kav line, and it's pronounced kav and should be kav, but it's spelled kaveh.
With the A, which is another letter that we don't use. When we write in Hebrew line, kav, it's 2 letters.
So kav 2 letters, kuf and vav.
Yes.
So if we know the gematria, so gematria is basically numerology. It's the numbers which historically every Hebrew letter of Hebrew alphabet has assigned, and that's kind of been fixed for centuries. So according to the gematria, to the numerology of the how it should have been done, kav is 106, kuf is 100, vav is 6, 106, but it's spelled kuf vav hey, which is 100, and 6 and 5, so 111. So, and fascinating thing is that if you just take 3 and make certain correction by taking the ratio between 111 and 16, you are getting the precision which was reached not so long ago. So you get properly, I think, 3.14159.
It's unbelievable.
Which is absolutely unbelievable, which is much, much better than the approximation, which genius approximation of
Archimedes, yeah. Right.
Which was 7 centuries afterwards.
This is just unbelievable.
When I just saw it, I got complete goosebumps because it's completely unbelievable. So my kind of personal, kind of more mystical understanding is that the wise people like Solomon, ancient sages, they somehow were given this knowledge, one way or another, from God, or how you see it. And the decision was taken, as with a lot of knowledge of those times, not to make it public. So for the normal person, a man or woman from the street, pi was about 3 and about that. But for people who knew about the situation, they could make this correction, and they can know the number which was only reached I think the very similar numbers were gotten by the fantastic Chinese mathematician of the 5th century, Zhu. He got approximately these things. But the better numbers were probably found in our time, 16th, 17th century, when kind of science in Europe went in gigantic way. So it is very, very interesting. There is another way which I can maybe next time I'll try to come with. That it was kind of a little bit of the approximation, because every next number of the pi were given through things. So, for example, 3, it's written there, and the 3 forefathers, Abraham, Isaac, and Jacob. Then there was 31 was another gematria, and 314 was another gematria. So it was another very interesting explanation. You can think about it. You can be. I don't like this expression. It's very popular in English. To being a devil's advocate, and say, look, what I just said. We don't. I don't think we have the written version of the Hebrew Bible until probably 10th century, 7th century. Recently was the Sinai Codex, I think, which was sold on the auction. I don't know, I haven't checked. It would be very interesting if the kings were found in the Qumrans, which was like 1st, 2nd century before Common Era. So if these things appeared at the same time when we find the first Hebrew manuscripts, namely 10th century AD, it would be still quite amazing. But it would be much less amazing than it was almost 2 millennia before, in the 10th century, 10th century before Common Era. So, but I just somehow don't think that that's possible at all, because the tradition, the Masoretic tradition of writing the Bible, was kind of very, very precise for many years. For people, of course, who believe in sanctity of the Bible, for them it would be very preposterous even say that. But generally speaking, from scientific point of view, I can't imagine that somebody very clever sage on the 10th century, 9th century of Common Era, in order to fit pi to the things, added letter He in this particular verse. And I don't think it was even known in the Middle East and Europe, these numbers, because I'm not sure that the Jews' improvement were known in Europe. When was it not known? So basically, I can't imagine. It's so much kind of like this.
Every way you're going to twist it around, it's just a remarkable achievement. And the fact that it's there, I think that people should pay attention to it, because sometimes we hear about, oh, the Bible got this code, that code, if you add this, you add that, and people almost trying to reach to find something that they want to see. But in this case, it's just unbelievable. And anyone who understands mathematics can't but appreciate it.
Because about this gematria, about this kind of code of the Bible, I hear a lot of kind of skepticism in the scientific community, that if you say take Russian alphabet and give them numerology, and take a big book like War and Peace of Tolstoy, or Shakespeare, or anything, you will find everything.
The monkey paradox, the monkey theorem, how they call it. When you take a monkey, you put him on a typewriter for a million years, and he's going to come up with Shakespeare or something like that, by probability.
But for me, what this kav and kave, it is so important and so kind of stunning that it is found in the same line, not in the same book, as I said, not in the same chapter, but in the same word. So coincidence would have been if it would be somewhere in the Bible, and it would be this.
Exactly.
So for me, just kind of like there is a consciousness, there is a kind of intellect behind it, and we somehow rediscover what this was kind of already done. The interesting thing would be, and would be extremely revolutionary, if these people already knew that kind of there was this secret knowledge.
Yeah, and it's amazing as well to think about how you see, because with Archimedes, for example, which was remarkable, maybe the greatest mathematician of antiquity, But you still can go and follow his writing. You can see that was his method. That's the way he went with these polygons. And as you said, he started with triangle, then multiplied it, and ended up with 96. So we understand the method. But how did they manage together? So unless maybe it's a godly knowledge.
It looks like this. And by the way, the kind of this the Chinese mathematician Zhu, he basically continued. I don't know if he rediscovered it or it was probably went through India, which got it from the Greeks or whatever. For him to get the same precision of the 3.14159, the polygon, which is inscribed within circumference, it's also 3 times 2 in the power of much, but it was much bigger than Archimedes. It was 24,000 something like this. I think it was yes, it was 142, which is like 1,000 and 2.9 times 3 times 8. So basically, it was 3 times 2 in the power of 13. So it's a huge amount. And that's the Bible coming up with this idea. Just exactly, it's very well spotted and just unbelievable. How did they get it? Again, I don't know. It would be very interesting to try to approximate it. How the precision which people had. As I probably mentioned last time, I was in South Egypt some time ago, and the guide told us that the one of the pharaohs. He ordered to design his and to locate his statue. So only twice a year, the direct sun was falling on his face or something like this, and was his birthday and the day of his whatever intronization or coronation. So, but generally speaking, kind of feeling of that time of the ancient Egypt was fascinating. How much people knew. Well, the other, I don't know, probably wouldn't still compare to the precision of the pi from this verse, but the Jewish calculation of the year, which basically makes 7 additional months in 19-year calendar, etc., etc. So basically, the problem with the Jewish year is as follows. There are kind of 2 main ways how you reconcile. So the issues there is that the solar year, which is about 365 and a quarter days, you can't really divide it, cannot compare it properly with the lunar year, which is 29 and a half. So whatever you do, it becomes like 12 years and 12 months and about 12 whatever days. It is quite important. So basically, the Romans, the Western tradition, they didn't bother about these things. They just kind of had the solar without any interest in the moon. So problem solved. With Islamic tradition, it's just like moon. So the year is 12 moon months, and again there is no problem. With the Bible, with the Jewish tradition, the problem was that the Passover is called the holiday of spring, and if we allow the year to be 12 days less, then the Passover will become winter, and then become autumn, and then become summer. The same thing like what's happening with Islamic tradition. Ramadan is moving every year from year to year. So, but because the Bible says that the Passover, it's the holiday of spring, Chag Aviv, it was impossible to not to make this adjustment. So the rabbis had to make the adjustment to add the months. But then it was calculated so well that it should be exactly like 7 leap months within 19 months circle, and there's also addition of the months. So it been calculated so well that it was better than the prevalent at that time Julian calendar. And Julian calendar was updated during the time of the Pope Gregory, so in the late 16th century, I think 1580 something, 1583, when the days were added, and so basically after that, the calendar became more precise. So basically, the idea probably of the Christian update of these things was the same thing, because the Passover and therefore Christianista was becoming shifting in the year, much more slowly than it would have been in other calendars, in the moon calendar, but was shifting. So basically, there were things in that calendar as well, which is interesting kind of calculation. But this particular one from King's 723 is a complete
takes the cake.
It's completely
Yes.
mind blowing.
Yes, I encourage anyone who is interested to check it out and see. And again, I would have loved to see if there was any method behind it, but I guess because it's biblical, we have to accept it as godly if we believe that the Bible is divine.
Well, who knows? Again,
Yeah, I'm not saying necessarily, yeah,
optimistic.
but yeah, I'm just saying if. Yeah.
We can be optimistic because we had certain ideas of say Babylonian culture until cuneiforms were found. When they started kind of to look at these things, and when deciphered it, we as humanity we deciphered it, or deciphered a lot of other things. Our understanding of the ancient world became much better. So who knows? Who knows how maybe there would be, I don't know, in 50 years time, 25 years time, 100 years time, we would look at the sort of manuscript and we can read the information what people thought at the time. I don't know, but it looks like we can't in this paradigm of thinking. So
A lot of information got lost as well. There was a big library, right, in that of Alexandria, that I think most of it was gone. Is gone.
yes, it is very, very interesting how unfortunately some cultures, in fact the Egyptian culture, it would be also very interesting actually to look at it at some point. Egyptian culture, which was dominating in many ways the Asian world. After the conquests,
The
Persian
first
conquest.
actually problem in math is that was ever discovered, something that was engraved is from Egypt. There was a problem in mathematics. I think it's the first evidence of someone posing a problem in mathematics. Before that Mesopotamia we had mathematics, but I'm just saying that's the first time that anyone posed a problem.
Yes, and then since about the time when first Persians and then first Babylonians and then Persians and then Greeks conquered in Egypt, there was we don't see much kind of openly, but again very interestingly that the library which you're mentioning, Alexandria, was in Egypt. Of all Hellenic lands, it could have been in Syria, it could have been in Asia Minor, it could have been in Greece itself. It was in Egypt, and it's again became like kind of a beacon of the world. In fact, one thing which I would love to talk to at some point, this confluence, this kind of marriage between the East and West, and East and West is very kind of relative, but between the Middle Eastern, which means the fertile crescent from Mesopotamia via Syria and Israel and Egypt, and the Greeks, was extremely productive for the Greek thought. It obviously would not be possible for Greek science, which has been very much a foundation of the.
That was a proper pilgrimage place, the Alexandria. I think all the scholars from the region just came and shared their ideas there and used to write them and keep them.
Well, yes, but also many of them just came and lived there. So I'm just reading biographies of ancient Greek masters, mathematicians.
Who used to teach them? Euclid.
Yeah.
Was Euclid the teacher there?
Yeah. So they would come in a way. It was a capital, intellectual capital of the world of this time, which is also very interesting because it was based on the kind of Middle Eastern land, and it used this Egyptian and other sources. But the achievement of the Greeks, the very beautiful achievement of the Greeks, and I'm sure
That's
you
exactly
would like to
the
say
mathematical
something
proof.
about it. It's a proof, and it's extremely methodical, deductive way of these
Exactly.
things.
Rigorous.
Very rigorous. In fact, I've been reading the things about the Romans very recently, about the Roman numbers, and with all huge respect for the technological genius of the Romans. Roman mathematics, Roman science was never anywhere like Greek.
As profound as Greek, because technology doesn't mean that science is advanced. I mean, and vice versa. I think there's a big problem, and we spoke about it, or maybe we did not, but maybe we touched it somehow. Is that unfortunately I see that a lot of people today try to estimate, and it goes a lot with some conspiracy theories or some pseudoscientific theories, whatever you want to call it, that they're trying to estimate the level of progress of a culture, ancient culture, according to the technology they had. You know, they come up with all kind of things like, oh, the Egyptians, they had the spaceships. Who cares? The reality is that Archimedes, they didn't need technology, because what they had in their minds was unbelievable. You understand? This technology is just, for me, in a way, it's almost an inferior manifestation of the way your mind works. I mean, it's almost like you got science, but you got so many different steps that you can climb, and people think that because people summarize it in the technological advances you got. They said, you know, Archimedes, what? He didn't even have a pen to write his conclusions. He used to, I don't know, probably use the sand. So, but his mind was incredible.
So in a way, you see it kind of the superiority of the pure mind,
the mind, exactly.
over technology. Well,
also, I think I read it once. There was the debates between the philosopher Plato was you know, so influential, and they spoke about mathematics. He was a great ambassador of mathematics. He was not a mathematician, but he was a great ambassador. And they spoke about it. If I remember correctly, in this discourse between them, they said that mathematics is one of the greatest wonders of the imagination, and it should stay there as much as possible, because they looked at it as that if we are using mathematics for practical reasons, it's almost like we are allowing it to be used for something much inferior than what it should be.
I remember this debate when I was about like 15, 14, and 13. That kind of among the kids who wanted to do mathematics, applied mathematics was a bit like, not quite swear word, but it was less kind of prestigious for some reasons. Kind of you are, I don't know, putting yourself down in a way. I don't know whether I fully agree with that, because over years I probably have a lot of respect into their applied things. Like, for example, there are stories, and again I need to look at it, but the Phoenicians not only went through Gibraltar Straits, but went around Africa and came back from the Red Sea. So which Europeans only could kind of repeat after Vasco da Gama in the very end of 1498, and then probably came to Red Sea probably already in the beginning of the 16th century. We also know very well that this kind of hypothetical, this imagination, as you say, of the knowledge, of mathematical knowledge, which was translated in many ways into other scientific knowledge. That was inspiration behind, to an extent, again it would be interesting to look and speak about it, inspiration behind Christopher Columbus going there, because it was known, the knowledge of the Greek knowledge of the hypothesis that the earth is round were kept through Middle Ages. So somehow there was expectation or idea that going west you can return from the east. Very, very interesting.
No, it is. I'll tell you something. I want to continue with what you said about you being a teenager, speaking about mathematics, and you grew up in the Soviet Union, right? Which is known to be an extremely powerful when it comes to mathematics. I'll tell you another thing just before I go. You know Gregory Perelman, who solved the Poincare conjecture, incredible achievement, the only millennium problem that was solved. He based a lot of his solution on Richard Hamilton, I believe, a mathematician. He came with the Ricci law, is some sort of a topological surgery that helped Perelman solve this problem. And I think, and Perelman recognized it and he gave the credit to Hamilton. But Hamilton himself said something like, he said, you know, if in the States, if we had the knowledge that the Russians had, I would have solved it. He in a way, he claimed that Gregory Perelman solved it. Of course, it's not like he took the credit for his incredible mind, but he said he had the knowledge that we didn't have because the Soviet Union was so powerful.
Do you mean there is a kind of that's very very interesting question? Do you mean it's a knowledge, written knowledge?
It's knowledge that apparently, according to Hamilton, what the Americans knew on mathematics was not as much, or in this case, at this particular discipline of topology, let's say, they didn't know enough as the Russians knew. The Russians, at any case, Soviet Union, you grew up, you know better than I, had such a strong school of mathematics and chess as well, that they were like a superpower. And in chess you had Butvinik, and you had great chess players anyway. You had Mikhail Tal and Korchnoi and Karpov and Kasparov, and the list is long. But the point that I'm trying to make is that according to Hamilton, he said the Russians knew a lot of things. They had such a development of mathematics between them that they had the tools that we didn't have. Because we have to remember, when we speak about mathematics, a lot of problems in mathematics, we had some incredible minds through history. But even the greatest mind, even someone like, let's say, Euler, taking as an example, which I admire, he tried to go with Fermi's last theorem, and he managed to achieve some proofs regarding certain powers. I think the power of 4, maybe 5, I don't know how far he managed to go, but he didn't manage to prove, to get the conclusion that it's going to be valid for everything from above 2 to infinity. Mm-hmm. Okay, but the point is that it still took 360 years to solve it because they needed to unify fields of mathematics in order to solve it. So there needed to be an evolution. You needed Taniyama Shimura, the two Japanese mathematicians, post-war, Second World War mathematicians, to come up with finding a connection between unifying modular forms and elliptical curves in order to give the power for someone later on to solve it.
To invent a language.
Exactly. So that's what Hamilton says about the tools. So that's one thing. But another thing, I'm coming back to your childhood. I'm trying to relate to it, and I think that the pure math is something so pure mathematics. There's something so romantic about it. It's an artist, an artistry. When I read the things that Euler did, I realized that the man was not just a genius and knowledgeable. He was very knowledgeable about. He knew everything about mathematics that anyone could know at that time. But he was an artist, he was a risk taker, he was a man with intuition, with feel about mathematics, with taste. I wanted to ask you about it, I'm fascinated. You know, he took risks, he did things improper, but he knew where he's heading. It's like he like broke the laws, he knew what, but he had such a strong intuition and so much experience that he was right, he knew what he was doing. Buzzer problem, but not just. Tell me about it, Misha. Do you feel it like that as well in mathematics?
Yeah, no, absolutely. Well, you just kind of now put it in a very different gear, which is very very interesting. Yeah. In fact, what you were comparing it with the arts when you were talking about Egypt and Alexandria, I was thinking for some reason about France and Paris of the end of 19th, beginnings of the 20th century, when people like Pablo Picasso, like Chagall, like Modigliani came from completely different parts of the world. But there were a lot of people who came even from outside of Europe. Why did they come? Because in order to create, there should be certain atmosphere. There should be people who appreciate what you do. So basically, you're absolutely right. What was created in the Soviet Union of that time, which I don't think exists in the same way anymore, unfortunately, that the mathematics and science was almost practically worshipped. I remember I was writing poetry about these things, and it was kind of like mathematics was the goddess, like a Greek goddess and things like this. So basically, it was really kind of almost worshipping something, this thought process. It was extremely important, to do something in order to maybe to surprise your teachers, or kind of to draw their attention, to deserve their their respect. So it's almost like, you know what it is, in some mystical or whatever metaphysical way, uh, when a person or group of people do something, there is almost the energy around them, or maybe not almost, energy around them, and it has dynamic of its own. And we know many examples of these things from completely different parts of their human, from science, for example, from the science comes, do you remember the name of this Hungarian mathematician who practically at the same time discovered Lobachevsky geometry?
Wait a second, you're not talking about Erdős. Paul Erdős?
I think it was.
I'm not sure. I know that Erdős is the most prolific by collaborations in history, because I always thought that Euler is the most prolific mathematician. Probably he was, but by collaboration, probably Erdős. You're talking about Erdős, 20th century Jewish Hungarian mathematician?
No, that was 19th century.
Ah, okay.
So the story was like this. Lobachevsky came up with his Lobachevsky geometry. And practically at that time, somebody like 2,000 miles, 2,000 kilometers from him in Hungary were coming up with practically the same ideas. So for about like 22 centuries, there was Euclid geometry, and suddenly almost the same months, two different people of the different things. It doesn't mean, of course, that everybody, every Tom, Dick and Harry in the world, and I don't know.
It happened with Leibniz and Newton. It's a bit different,
Exactly.
but it's similar.
Leibniz and Newton. There were quite a few people, like discovery of the radio. Also, were quite a few people for up to now. Russians say it's Popov has invented it, and Marconi is in the West, and does it really matter? But the idea which I really kind of try to put here, which it's almost the idea is there, is waiting to be born, to come through somebody, right? About intuition, actually, very interesting. I not so long ago, I read somewhere intuitions. So you're tuning from within. Probably everybody know about the dream of Mendeleev, of the Mendeleev table. It kind of came to him in kind of, I wouldn't say like supernatural way, but maybe it is, because kind of now when we have Mendeleev table, it looks like obvious, more or less, but it's humanity lived without it for centuries and centuries. So the same thing. Do you know this experiment? Very beautiful experiment about the monkeys in the different islands.
Tell me, I don't know, maybe.
So apparently the monkeys obviously can learn to different skills.
Then the skill is getting almost transmitted.
Exactly.
Yeah, I've heard
so
about it,
so the monkey was in
lately, by the way, someone spoke with me about it.
Yes, well, a few years ago, I don't remember, I was reading that, which sounds completely supernatural, that the monkeys was shown how to open like a tin of tomatoes or whatever it was, and suddenly within like very short period of time, minutes or whatever, other monkey in the island like 50 miles away learned how to do it. So kind of, which in a way, if we think about it, sounds like very spooky. But if you think about quantum physics and I don't know, universe and anti-universe and matter anti-matter, it might not be. So, but in the religious way also, it was known probably, at least what I know, the story of 16th century. I think of Rav Yosef Karo, who is the author of Shulchan Aruch, of the kind of the religious code. I think it was in his time that he was not dissimilar in a way how like humanity looking at the scientific like millennial problems. He was looking at his problem in his religious field. I don't remember what it was exactly. And it took him like years or decades, like 24 years or so, to solve it. And the moment he solved it, maybe next day or day after, somebody who was no close way on his intellectual abilities started to explain to a friend of his, and he overheard this, is how it's possible. And he came to his teacher, to even wiser and older person, and said, teacher, how it's possible? I've worked on it 24 years. I didn't tell anybody, and suddenly this guy who is not like anywhere near me on the intellectual capacity said, you know what? Your achievement, it's your achievement because you worked. You kind of drew this canal.
You really labeled it.
You labeled it, so it is even without you.
You created the quantum tunnel for that. Yeah.
Exactly.
There was Newton and Leibniz. Who knows? What was there going on there?
Yes. So in a way, and it's
great minds think alike.
Yes, and but interesting that not only they think alike at the same time. So
Yes, exactly,
it happens. It happens every so often. But generally speaking, what kind of I'm trying again, what I'm just seeing at the moment, and the more I read, the more fascinating it is. That I don't know about you, but many people, and I probably in the past, I was looking a little bit down at ancient people. Like, we have our spaceships, we have our this and
I definitely
that.
not holding these opinions. But it took me time to, of course,
Yes.
realize and understand it. Yeah, I think that personally our technology today is remarkable. You can put in your pocket a computer that would put to shame anything that you. It's incredible how fast it has evolved. But still, it doesn't mean much to me. When I look at how the minds worked in the past, I think that people today became very passive. Not everyone, but most people are not using their minds, and they think that because they can use the technology, that means that they became smarter than Archimedes. But oh my God, this is not even close to. Yes.
Yes, but I was just reading recently. So there, in ancient Babylon,
Mm-hmm.
because obviously there was the system based on
360.
and 1/60th, right? So basically, they had something which we in a way rediscovered, if I may say so, when we learned at university about the binary system and then 16 based on 16 or 8. And when you look at their system based on 16,
Mm-hmm.
because our Hindu-Arabic numbers are not enough, from 0 to 9, we had to introduce 6 different things to cover from 10 to 15,
Mm-hmm.
right? So why it is again? Why it is popular in the modern time? Because when we do computers, in computing, obviously there is a binary system, yes or no. Our decimal system is not particularly good for that because it's not basically power of 2. So would have been much better if our system would be power of 2. So 8 would be one of the solutions, but many people like 16, which is obviously 2 in power 4. But you need to have so many symbols as the power of the system. So in our decimal system, we have from 0 to 9, which covers us for whatever we need for that. In the 16, we would need 16 digits. For first 10, we already have from 0 to 9, and for other 6, from 10 to 15, they used the Roman numerals, letters from one to F. And you know what? I was kind of struggling with this thing as a student, kind of trying to write things and multiply, divide, and 16th based system. And I'm reading about ancient Babylonia, and they have 60. So they have from 0 to 59. So in a way, I believe a student should have timetable, not like 10 by 10, not 12 by 12, but 60 by 60. So you should remember like 3,600.
Yeah, tough life back then.
Tough life. So basically, like to look down at them, and it's extremely preposterous. And in fact, the way how they came to these conclusions, their dedication to their things, the geniuses of these things. Because so sorry, I'm probably so kind of obvious, but how many people took bath in life? Like billions of people, and billion times, people go. Archimedes kind of got his
got into
bath.
and he solves the problem, for the king. And that was nothing in comparison with his math. People remind him for some of his inventions, the screw, the Archimedes screw, and then the famous story about the bath, Eureka. But his mathematics was unbelievable. You remember the sand reckoner that he had this? There was another challenge from the king, to find out how many sand grains are in the universe, the known universe. Remarkable minds, and with so little technology to their aid, I mean, you don't need anyway. I think it's safe to say, and you'll tell me as a mathematician, that let's say someone, God forbid, put you now inside a shelter. You are by yourself. We just give you a piece of paper and a pen. Do you need anything more than that? I mean, you got your mind. You don't even need that. But do you need more than that in order to? You don't. That's the beauty of mathematics. You don't need a laboratory. You are not an empirical person. You can live inside your own mind. It's incredible. Don't you think so?
Yes, well, there was a story. Yes, well, because the mind actually feeds on itself, and the advantage, and I try to be correct and not offend everybody's feelings, but the one reason which mathematics was so attractive when I went to university, that we knew that, for example, if you look at the physics or chemistry, Soviet Union and Russia at that time were already kind of bit behind, say, all the best universities in America, for example. So in a way, it probably, again, in my teenager's mind, I was thinking like you would have to compete with people, if you compete with people, on kind of their equipment, which is inferior. In mathematics, there is no such problem.
You don't need it.
But in a way, you can compete. Sometimes there was a story, I don't know, it's an apocryphal story, about underfunding and kind of ingenuity. There was a very big problem in, sounds too simple to be true, but well, I'll tell you what I heard. So in the 60s or 70s, there was a very big problem how to get in space a pen which would be working.
The ball,
yes.
Yeah.
And apparently somebody in a laboratory in Moscow, somewhere on a space laboratory, says, okay, you don't have to spend the millions of dollars or billions of dollars, take a pencil.
The Americans, they like spending, huh?
Well.
They like the idea of spending.
Well, it's benefited some professors and gave them opportunity to kind of to thrive. But what you're saying about the time, about time of the Soviet Union and the scientific thing, again, and I know some people who really admire this time. And again, I absolutely don't want to be nostalgic, and I don't want to to talk about the kind of what period of the time is better, or what culture is better. In fact, if we started this evening from King Solomon,
I think it's exactly.
King Solomon said, "Whoever thinks that their old time are better than now is not particularly clever, is not particularly wise." But the idea was, and actually there is a strength and beauty of this idea, and not kind of parroting and completely mimicking the time, but to use strength of the time. Why it was so popular? Because in a way, it was very unusual time, and people could not travel. It was very difficult, for example, for somebody to go and to immigrate. So people, in a way, the talented people, talented young people, would stay in the country, stay at the university, and there would not be kind of brain drain in many kind of cultures, many countries, including Israel, lost a lot of talented people for American universities, not being anti-American for slightest, but understanding.
But it's a reality
kind
if you're offering them good money, and that's the incentive for everything. So
it was practically impossible for a Russian scientist to do this. The only way would be to go to international symposium and defect, but that would be probably possible never to see parents and probably children.
And you have to be very good, I think, in order to actually.
Yes, and so people were kind of, in a way, constricted in the place where they live. The second kind of things, which is probably not dissimilar to America, but probably even more so, the concentration. I've actually never thought about it, I'm just kind of thinking about it as we speak. There was very few laboratories and scientific places, which were probably mostly in Moscow and in St. Petersburg, other places. So they would be sucking, they would not losing people to America, but they were sucking intellectual people from at least from all over Soviet Union, sometimes the Eastern Bloc. But that's kind of all good. But probably even more importantly, there was a culture of creativity, the culture of loving and worshipping this scientific knowledge. You will be very respected you probably would date a more interesting person if you are successful.
Mikhail Tal, who actually was a great chess champion, he was a bit of a rock star. I think he lived like a rock star. He was married several times. He loved a good life. So yeah, chess.
Well, I don't know. Forgives me one person I probably can say was one very famous academician of Soviet Union who later immigrated, I think about in 1988 to I think to Rutgers in New Jersey. He last time I think he married his PhD student when he was 65 or something like this. So basically, these people had
the celebrities.
Exactly, they had status of Kardashians. I don't know.
Kardashian. And that's what the Soviet Union wanted to show. They wanted to show how great was very important in the Cold War, to show to the world that look, while the Americans, and by the way, I'm not giving my own opinion, I'm just saying it as it is. The Americans, while they are interested in consumerism, look what we are doing. We are showing superiority. Intellectually speaking, we are superior to them. And Bobby Fischer, coming back to chess, I'm a big fan of chess. You are playing chess as well. And he actually was the American who stopped the Russian machine, at least for the Soviet machine, let's call it this way, at least for some time. He really managed to beat the beast, which was unbelievable because it was a very powerful, probably the most powerful nation when it came to chess as a collective effort. And yes, it's pretty much what the Soviet Union wanted to show. Look, we are intellectually, we are up there. We are not interested in this American habits, lifestyle.
Yeah, kind of two things for these things. One thing is, of course, that part of what he was beating, the system was, and also it's very, very important. People try, and I don't know where it comes from, to try to put very, very simplistic, very binary things, good, bad.
Yeah.
Soviet machine has a good and bad. The good thing was that was enormous number of extremely intelligent people in chess and other places, probably disproportionately high for quite big but not huge population. But also the state machine tried to cheat apparently, because I know the stories that
Karpov and Kasparov, you mean? They used to. Bobby Fischer said that he was really upset about what was going on. That they said that they moved they actually made the games between them. I don't want to get too deep into
no,
that.
I mean, I'm not thinking about the Karpov Kachnoi and Karpov Kasparov. I think which is probably minefield, a separate conversation. But I mean the kind of accusation which I think is very, very likely, that because, for example, in a tournament, say Bobby Fischer would be the only non-Soviet person, and would be, say, 5 Soviet ones. Then if they have certain agreements, and there was certain situation, they draw each other.
That's what they said about Karpov and Kasparov.
They would not allow the non-Soviet person just to go and to challenge the system. So that was obviously unfair. But that doesn't take away from the fact that the intellectual climate that was created was very, very high. The other things which is very interesting, and which what happened in the post-Soviet countries, not in Russia only, but other countries as well, after the collapse of the Soviet Union in 1991, people got a lot of opportunities. People could immigrate, and a lot of people immigrated. People also start to do business, because in the Soviet time, there was a pulling factor and a pushing factor. The pulling factor into science, welcoming factor was not only you become very popular, and people love you, people worship you, and people 40 years younger you want to marry you, but also they created a financial situation. Officially, if I'm not mistaken, the best person, the person who was paid much more than anybody else, was not the director of the factory, not the director of Baikonur, the space things, the chairman of Academy of Sciences of the Soviet Union. He got more money than anybody else. In fact, probably it wasn't that way, but it illustrates the things that if you are, from the point of view of the legal salary, the best paid people were PhD people, professors, academicians. So it was kind of very, very clear statement.
Of the priorities, yeah, in the country.
The other thing is actually it was completely shocking when I came first to London. I wanted to go to university. I wanted to go to Imperial College actually of everything, and I was asking people around, where's University of London, Imperial College, and nobody knew. Everybody kind of who spent the day in Moscow knows, or probably never.
But you ask them where is the O2, they will know immediately, yeah?
Yes.
You ask them whether the O2 or...
Yes, and the tube station is called University, and it's probably as much
or Camden Market, yeah.
Exactly, Camden Market. So basically, this in a way perceived for me that time anti-intellectual.
Yeah.
Yes.
By the way, just a question: when you so you studied in Imperial College, you did study there?
I didn't study there. I did some scientific work there for some time.
Okay. How did you find the level of the people? Because again, you came from a place that had really the highest level, Soviet Union, probably the highest level, or at least among the highest levels.
I probably was very lucky. I was in a very, very good and creative place in Imperial.
So you find like-minded minds and people and...
I was fine, but I heard, and again, I don't know if it's bigotry or whatever, but I heard from, and again, I was very young. Maybe if I spoke to people, so I was kind of 20s, but I spoke to people who were, say, 15, 20 years older, like late 30s and early 40s at that time. They were very dissatisfied. One of them said about one of the universities, one of the leading universities in the UK, not Imperial, not Cambridge or Oxford, but one of the leading universities, he called it a puddle, kind of with a full of kind of sunshine. So basically, he found this extremely shallow. Again, I don't know. I'm very optimistic by nature. Maybe that helps me, and I try to kind of find the positive things. What in a way, I won't say upset me, but surprised me, and still surprises me that and you might have looked at it more than I, that according to official leagues of universities, say Moscow State or other leading universities of the former socialist countries, they never got the same prominence as Western universities had. Also, the interesting thing is, and again, is it technology or whatever, the number of the Nobel Prize winners from the countries are relatively small.
Yeah, but it's very political, the Nobel Prize, as well.
That's probably the answer.
I would not.
It shouldn't be that.
I would not trust it. Anyway.
It shouldn't be that way because
for me, it's not.
Because the scientists, they were not. In fact, of those years, these people, and many of those people, were very much against of what was happening in the Soviet Union. In fact, they probably underappreciated that this kind of, I would say what happened in the Soviet Union at that time, it was a little bit of a greenhouse environment. It was as if there was atmosphere created for these tomatoes to grow.
Flourish, to get
to flourish. And of course, in fact, an ironic thing is these people were fighting against the Soviet system. Academician Sakharov was one of them, but he was not the only one. Or they passively hated it, they cursed it in their hearts. And when the system collapsed, it's basically ruined their lives, so their scientific careers. Because what happened after the collapse of the Soviet Union, the money, the currency completely basically lost their value, and many people were reduced to poverty. It was good for people who were younger, whose family could immigrate, who left. But many people had young children, elderly parents, sick parents. Not everybody could leave. Not everybody. It was a very interesting conversation at that time. That if in order to immigrate, you had to be either a genius or young. But there were people who say, well, over 35, over 40, over 45, who probably were not scientists of the, not necessarily like top people like Kolmogorov or Tikhonov or somebody like that, who were not alive at that moment. Not the kind of the top mathematicians, but or physicists or chemists, but people who would be who said something very important, whose quotation.
Yeah, very good, yes.
Yeah, because I was privileged to work with somebody who very easily got professorship in the West. But and he was probably 53, 55 at the time. But not everybody, very few people were on his level, and there were a lot of people who were creating this fantastic energy, fantastic environment. These people who would come to these beautiful seminars, people who would ask fantastic questions, people who would be working, the school of people, because nobody, well, we don't know about Archimedes, but definitely Pythagoras and many other people, they had school.
Mm-hmm.
So many people who achieve things in their scientific progress, they would have somebody said, you will do this and you will do this, and together we'll as a team. So sometimes it's not only achievement to one person, but achievement of a group of people. It reminds me actually the painters that the painters, when they were doing some big things, they were not drawing every single square inch of the things. There would be was one person who was a specialist on the back of the horse. So he would be coming and he was doing for his master, with his teacher.
Yeah, I read recently about, because I'm very interested in Jean Delacroix, about his murals. He did some of these. Fantastic, yeah. Yes, you need a team of people with you.
You need a team of people. So, and a lot of these people suffered, and I know a lot of people kind of more my generation who were very young when these changes happened. And there, if Soviet Union would kind of endure, not a bit Soviet Union, but this kind of situation would endure, then they probably would dedicate their lives to mathematics or physics or chemistry or biology, and they would achieve things. Instead, they went into the business, into the earning money.
Yeah, that's you leading me to a question I wanted to ask you. It's about, well, once you started doing mathematics as a job, and a lot of applied, a lot of practical, working for, let's say, banks. Did you become disillusioned? Did you fell out of love with mathematics?
That's you asking a very personal question.
Only if you want to answer.
To be honest with you, it happened to me already when I came here to the West, and it was shocking. In a way, I don't think I am like that. I don't think I'm very materialistic. I don't think I am into the into kind of thinking like to gratify my ego, and I need to be the richest person in the universe. But the way how British scientists have been treated, they were very, very dissatisfied. My kind of time doing science in this country was difficult for me from the point of view the amount of complaints I heard from professors, from people of different ages. All of them were older than me, but some of them were early 40s, some of them were in 60s, some were in 50s. They were complaining the salary was small. A lot of people were kept in postdoctorates for a very long time without giving a tenure. There's politics. Politics exists everywhere, but that the publish and perish culture, then you have to be connected and basically in order to publish, rather. So basically the quantity, not quality of your scientific research was appreciated. But then I saw very unpleasant things where certain professors would have only foreign students. Could be from Soviet Union, could be Polish, could be Iranian, could be Chinese, could be anything. But normally people from outside of the Western countries, or what's called Western countries then, and we were, let's say slaves, but we were very dedicated, and we knew that it was very important for us to do things. And there was certain feeling then, and there's certain feeling now that we were exploited
Mm.
in a way probably which is not becoming to them, to their I don't know, cradle of democracy and etc. But we know about these things. I'm not the first person who talks about it, and hopefully it's not. I'm talking public maybe first time, but it was quite hurting in a way, because my vision of the West when I came here was it's much fairer and much more, at least in the scientific community, and it wasn't kind of the quality of mathematics. It was not even money as such. It was the whole lack of respect and prestige, and a certain discrimination. And well, one example I can give you that not only my professor, but his best friend wanted to sign papers which were 90-95% mine, which my professors in Moscow did not do. Well, I was maybe fortunate, because my professors were saying, okay, that's yours, you sign with my name.
I would absolutely
Even
agree,
if they looked at it. But that was kind of scientific supervisor's job to look at these things. But when I had, and when their names started from the numbers for kind of early in alphabet, and my name was third. If there is, as you probably know, if there are more than two authors, it becomes first name, and then in Latin et alias and others. So even my name was not mentioned in these things at all. It was very controversial, and actually was quite well known in the Soviet Union, the matter of anti-Semitism in the Soviet Union, that a lot of time the Jewish person would invent something and then his name would not
That's
appear.
I think with Kasparov it was like that. No, he's
Kasparov as
Weinstein.
well. He's Weinstein.
Weinstein. It was not advised for him to keep Weinstein.
Yes, but to come to the West and to experience, not because I'm a foreigner necessarily, but with the treatment, because I'm younger, because I'm not established, but maybe that's the way of life. And so basically we didn't have things which in the creative community, when you have to, I don't know, to have certain relationship for the manager to do this with, that didn't exist. But,
No,
but
but
it was
did you feel inspired? Look, my
Feel
question,
inspired.
my question is like that. You can be, let's say you're a musician. I play music, or at least that's something I've been doing for many years, and I remember I don't like tours. I don't like it. I don't like this lifestyle, but I really love music. And you can play music. You can earn very little. You can see that you are not financially, you're not going to be stable, but you love it, and you're being very inspired, and you're excited, and you feel that you got to do it. Especially if you got good musicians to play with. My question is that did you feel inspired? You felt that there is a lot of, you woke up every day with some incredible thoughts in your head. You say in your head, and you said to yourself, "Oh yeah, today I'm going to do something fantastic. I'm going toward the discovery." That's what I mean. Even if you didn't get the respect or was not necessarily financially stable, that's what I'm talking about. I'm talking more about the.
well, and again, that's again a very, very good point, because you're probably touching on on the thing that if you compare musicians and generally speaking people who in the creative things,
Creative people.
we just mentioned Chagall and Modigliani and Picasso. There were, I recently, relatively recently, heard a fantastic lecture about the whole group of people who came with at the same time as Chagall, who were fantastic people themselves, like for example Chaim Soutine.
Soutine, fantastic, yeah.
Apparently Soutine was so hungry that he was drawing to people, please feed me.
It's a similar story with many artists.
Yes.
Usually their paintings are being sold for millions, but they never had the chance to benefit from it.
It's just honestly, it just moves me to tears about this thing.
Yeah,
Because these
I
people
think
are
that
fantastic. So we can't. The scientists, I mean, we were not in this situation. We were not in the situation that we were starving, or it just felt unfair in certain ways, and it felt the kind of the power and the glory was distributed in a way. No, maybe not power, but the glory was distributed very differently in the West than in Soviet and post-Soviet and immediately post-Soviet times. But from the creative part of things, no, I was absolutely excited. I was coming.
That's good.
I was coming. One thing that was very surprising for me in a way, and sorry if I'm kind of very, very frank about these things. I was coming and I was studying sometimes in the evenings, and once I think I came Sunday evening because I was preparing something, and there was only foreign students, mostly from Chinese-speaking world. And I had a good friend who was a Chinese from Malaysia, and he did confirm that they got used to kind of 14-hour day. But the Chinese speaking, there was a feeling that back in Moscow State, I would go to the library and I would spend much more time in the library than it was expected from me probably when I was here. So I was continuing in this kind of interest and devotion to these things. My kind of path, my decision to go into more applied mathematics was not, in my humble opinion, how I see myself, betrayal to mathematics, but the recognition. Well, I met somebody who was a mathematician who and in fact actually a religious scholar at the same time, who really encouraged me to go to this world. And the mathematical problems which I had to encounter, they were as interesting as in pure mathematics, maybe more academic mathematics. But of course, in a way, you are getting different financial situation in banking, and it comes with a price. But I wouldn't say the price you pay is the interest. The price is the quality of mathematics which you produce. The price, I would say, would be more amount of time when you mix with people of your own.
I understand.
Or things like this, for example, I remember going to the bank and somebody was interviewing me, I think it was one of the first, before my first bank probably, and somebody was saying, oh, you look very academic, don't worry. I felt very good about myself, I thought academic is great. And the next sentence was, we'll beat it out of you.
Oh my God. No.
And it's not particularly nice when something of you is beaten out of you.
You
and
wonder if you're at the right place when someone says something.
Yes, but still, was enough of us, and usually being a mathematician in a financial institution, people usually respect you because they know, and they say it and they know it, that they can't do it. That you might, if you so kind of predisposition, whatever, learn to do what they do. They know they can't do what you do unless they had similar background, because there are mathematicians who are working as a traders, etc., etc. But so you do have respect, but you don't have time particularly. Again, unless you go and you become like I don't know, a guru of financial mathematics, or you work part-time in the bank, part-time in the academia. But normally, if you work full-time in the bank, you don't have time, you don't have pleasure to travel to France or to America to the scientific congress. You probably work so hard you don't have much time to read scientific journals. It is a different life.
I understand. No, I understand. Listen, Professor Misha, it was a brilliant talk. I think we should leave it here and just
we went very far from pi and from
never mind. This is how we do it. That's
yes.
this is our method. Talmudic. Everything is Torah, as the Rabbi said. No.
Yes. Well, basically, yes, because in a way, and finishing on the kind of Asian
You
thing.
can lead us into the end.
There, I idea to separate things in mathematics and physics, or I don't know, differential equation, linear algebra, it's very very modern things. In time of Archimedes, it was not separated so much. So in a way, we follow a good example. We kind of take these things from different parts of the life. Okay, thank you very much indeed.
Thank you very much, Professor. Until the next time.